Okay, welcome back, kiddos. Now we are going to move on to properties of trapezoids. Okay, so these are these types of shapes that we're going to be talking about today. Okay, so let's get into some definitions. Okay, so first off, a trapezoid is a type of quadrilateral. Quadrilateral, right? And we talked about what quadrilaterals are last time, which means four sides, right? So some essential vocabulary. First one are bases. Okay, so the bases are the parallel sides. Okay, and those are usually the top and bottom. Okay, then the bases of the parallel sides, the legs are the two sides connecting the bases together. Two sides connecting the bases. Okay, so then a diagonal. We kind of know what a diagonal means. We talked about before, and so diagonals are the lines drawn from one corner across to the other corner. Okay, so it's across to the other corner. Okay, then we're going to talk about base angles. So it's using that base. All right, so the base angles are the angles at each end of the bases. At each end of the bases. Okay, so those are called the base angles. Okay, then our last term, consecutive interior angles. Okay, consecutive means in order. So consecutive interior angles are two angles on each side connecting the bases. Okay, so those are our terms. The parallel sides are called the bases. The legs are the two sides connecting the bases. Diagonals are drawn from one corner across to the other corner. The base angles are the two angles at each end of the bases. And then consecutive interior angles are the two angles on each side connecting the bases. Okay, so let's go ahead and go through that as we apply it. Okay, so first we're going to talk about two different types of trapezoids. Okay, so the first ones would be called non-isosceles trapezoids, and it looks like this, and then isosceles trapezoid, which looks like that. So you might be able to tell a little bit of difference right now, but we'll get right into some in-depth stuff. Okay, so a definition of a non-isosceles trapezoid. Okay, this is going to be a quadrilateral, right? We know with exactly one pair of parallel sides. So one pair of parallel sides. So if we look over here, okay, this tells us parallel, right? This tells us parallel. Okay, so these are the bases. So these are the parallel bases. Okay, so that's what we talked about. Is basically the top and the bottom. So this right here and this right here. So the parallel sides are going to be, we would say EF, right? EF. And what else? We would say HG or GH, right? GH. Okay, so those are the two parallel sides. Okay, next, the non-parallel sides. Okay, so if these two are the parallel sides, the non-parallel are these right here. We know those aren't parallel. So HE or EH, right? And FG. Okay, those are new non-parallel. And then we have two pairs of consecutive interior angles. Two pairs. So we said the consecutive interior angles are the two angles on each side connecting the bases. So this angle right here and this angle right here. Those two angles are connecting the bases. So we're going to say this is a pair of consecutive interior angles. Okay, and then these two right here, those are also consecutive interior angles. Okay, so a non-isosceles trapezoid is going to have a pair of parallel sides, pair that are not parallel, and then these two are called the consecutive interior angles. Now, the thing about these consecutive interior angles is that these are supplementary. Okay, and we know what supplementary means, right? It means it adds to 180. Okay, so if we know this one, then we can calculate the other one. All right, so those are the properties. Let's get right into some practice on it. All right, so let's take a look at this first one. This wants us to find, it says the measurement. Okay, this is the measurement of angle M. Okay, so this is angle M right over here. Okay, so if we said this angle right over here, that's what we want to try to find. We could just mark it with one arm. Well, what do we know? This is this one has one pair of parallel sides, right? And then two that are non, so this is a non-isosceles. So we said that those are supplementary. They add to 180, right? These two add to 180, right? Add to 180 degrees. So if they add to 180, to find this one right over here, I would subtract that from 180, right? So I'd say 180 minus 87, and that would give me 93 degrees. So that's how much this one right over here is. That's 93 degrees. Okay. Then, similarly, what about K? Okay, well, what do we know? If this is parallel and this is parallel, then we know K and L add to 180 degrees, right? So that means if I said 180 minus 51, that would give me the value of 129. Okay, so that would mean that this one right over here is 129 degrees. And so those are our two answers on this one. Okay, this is 93 degrees right here. Okay, and this is 129 degrees right there. All right, so let's keep it moving. Now, what about this one? Okay, now this is the same thing, except for it's stepped up with algebra. Okay, so they want us to find the measurement of angle O. Angle O is right over here. Okay, so that's represented by 7x minus 3, right, degrees. So that's how we know it's this one. Well, if we need to find out this, the first step we want to do, step one, is we're going to set it up. Okay, step two, set it up and solve. Okay, step two is we're going to substitute. Okay, so let's do step number one. We're going to set it up. Well, what do we know about these two? If this is parallel with this, then we know these two add up to 180, right? We know it has to add up to 180 degrees. So let's set it up. We're going to say 12x plus 3 plus 7x minus 13 equals 180, right? So that's where we set it up. Now let's just solve. We know how to solve that, right? Let's maybe change this color so we draw a line down there. We know first we're going to do is combine those like terms, right? So 7x and 12x gives us 19x, right? And then I got positive 3 and negative 13. If we put that in our calculator, positive 3 and negative 13, it gives us negative 10, equals 180. Right, now it looks a lot easier, right? We're just going to solve by adding the opposite of that 10 to both sides, right? Cancels out, so 19x, we bring that down, equals 190, right? You may already be able to solve for x in your head, right? If we divide that side by 19, divide that side by 19, x equals 10. Okay, so we're going to use that into step number 2, which is substituting, right? We said step 2 substituting. So let's take a look. They want measurement of angle O. O is represented by 7x minus 13, right? So we're going to say 7x minus 13 is equal to 7 times the quantity of 10, right? Minus 13. So I'm sorry. Yeah, minus 13, right? So if we put that into our calculator, 7 times 10 minus 13, that's going to be 70 minus 13, which gives us 57 degrees. Okay, so that's our answer. So we're just going to follow the same steps. We're just going to set it up using our algebra and then find the answer right there. So what we knew is these two add up to 180. So we just set it up and solve. Step 2 is we substitute back in because they're not asking for x. If they want x, that would be our answer. But they want the quantity of that. All right, so let's move it along. Properties of isosceles trapezoids. Okay, so isosceles has all the same as non-isosceles plus, all right, so here's the key, plus the legs are congruent. All right, so that's what the isosceles means. Isosceles means legs are congruent. Okay, and so then on the non-isosceles, the legs are different. Okay, that's the main difference. Okay, so you see right here, they both have parallel on top and bottom. It's just these two legs are different. These two legs, as we see right over here, by this indication, it tells us that these are congruent. Right, legs are equal. Right, it's a leg. Right, this is a base. Right, and this is a base. Okay, so the legs are congruent. The diagonals are congruent. So these right over here are the diagonals. Remember we said a diagonal, it's a line drawn from one corner across to the other corner. Okay, so from one corner right over here across to the other one is that. So that diagonal is equal to that diagonal. Okay, those are congruent. And then each pair of base angles are congruent. Okay, so we said the base angles, definition of a base angle, are the two angles at the end of the bases. So if this is the base, we would say that one of the base angles is this right here, BAD. So we would say angle BAD and angle CDA. Right, angle CDA. Okay, what about our diagonals? Which ones are congruent? AC, right, is congruent with BD, right? Those are the diagonals, right? And then our legs are congruent. So AB is congruent with CD. So AB is congruent with CD. All right, so that's the basics of that. So let's go ahead and get right into our next part of the practice. So that's the main difference. Non-isosceles, the legs are different. Isosceles, the legs are the same. Okay, because they're the same, diagonals are congruent and base angles are congruent. Otherwise, they're not. All right, so next, let's get into the mid-segment of a trapezoid. So this is the main part where we do our calculations. So mid-segment is similar to the mid-segment of a triangle. The mid-segment of a trapezoid is parallel to each base, okay, and connects the midpoint of the legs. Okay, so parallel to each base, right? So this right here, this one is base number 1, right? This one out over here, right? That's going to be base number 1. This one over here, right? That's base number 2. Right? So that means it says it's from the midpoint of the leg. So if this is a leg, that's a leg. If these two are equal, right? That means that's the middle. Right? Then it says this one equals this one. Right? If that's that means that's the middle. Okay, so this right over here, this is called the mid-segment. Okay, so we have the base on top, base on the bottom, and then the mid-segment. Okay, so the mid-segment of this trapezoid would be called MN. Right? The parallel segments, we have 3 of them, right? This one is parallel to this one, which is parallel to this one, right? That's how we see that symbol right over there. That means parallel, right? So the parallel segments are going to be AB, MN, and DC, right? So here's the mid-segment formula. Here's the main thing. The length of mid-segment length is going to be equal to base number 1 plus base number 2 divided by 2. Okay, that's our mid-segment formula. Base number 1 plus base number 2 divided by 2. Okay, and because its length is 1/2 the sum of the lengths of the bases. So sum means we add the lengths of the bases. So base 1 and base 2. And then 1/2 means divided by 2. Okay, so that's the same thing. The length of 1/2 the sum of the bases is right there. All right, so keeping that in mind, let's get right into some practice. Okay, so let's take a look at this one right over here. It wants to find the length of CD. CD is this right over here, right? So CD is that right there. Well, what do we know? If this is parallel with that, this one is, we can say that's base number 1, right? Then we could say this one is base number 2. Okay, so if we're trying to find the mid-segment, we would say that's equal to, we would say mid-segment is equal to base number 1 plus base number 2, right? Divided by 2, right? So that means CD equals base number 1, which is 12, right? Plus base number 2 is 36, right? Divided by 2. Okay? So if we put that into our calculator, we are going to get the answer of 12 plus 36 is 48, divided by 2 is 24. So CD is equal to 24. Okay, so that's our calculations right there. We're just going to add up the bases and then divide by 2, right? Because that's what half means, right? Divide by 2. All right, so let's keep that in mind. Let's keep it moving. All right, so next, this one right over here, CD, right? CD, this is switching up. CD is this right here. Okay, so that's what we're trying to find on this one. Okay, but is that the mid-segment? No, that's the base number 1, right? Because we see that they're parallel, right? And that's parallel. So that's, if that's base number 1, this one is base number 2, right? Then this one is the mid-segment. All right, so let's set it up, right? We said the mid-segment is equal to, let's just put it like this, B1 plus B2 divided by 2, right? That's the same thing as what this means, right? So let's do that. The mid-segment, which is MN, right? Let's put that, right? That's going to be 1.8, right? Equals, right? Base 1. We don't know base 1 yet, right? So what can we put to there? We'll mark it with X, right? So X plus base number 2. What's base number 2? Base number 2 is that 0.6, right? So we're going to say X plus 0.6 divided by 2. Okay, so now that looks pretty gross, right? So what do? We are going to cross multiply. So to cross multiply, what we're going to do is we're going to make that over 1, right? And we're just going to do our butterflies, right? So we can say that this times this equals this times that, right? So I like to work with the one with the X first. So that's actually pretty easy, right? 1 times anything is the same value, right? 1 times X plus 0.6 is still going to be X plus 0.6, right? Equals the other one, right? 2 times 1.8. If we type that into your calculator, we would get 3.6. Okay, so now that may look like it's quite easy to do, right? So if we do that, we're just going to subtract our 0.6 there, right? If we do that, we're going to subtract our 0.6 there. That cancels out, so X equals 3. Okay, so that's our answer, because that's what we're looking for is X, so X equals 3. Okay, so that's our main thing that we're going to do is we're just going to set it up exactly the same using this formula. Okay, so now let's move on to our last one. This is the highest level one. We got this. See if you can at least set this one up on your own. All right, so EH, what are we looking for? We're looking for this right over here. Right, so let's kind of indicate that one. That's what we're trying to find. to find the length of. So looks like we need to substitute at the ends, right? So first thing we're going to do, step number 1, is we're going to set up and solve using cross multiplication, right? And in step number 3, we're going to substitute. Okay, so step number 1, let's set it up. We're going to say that we said if this is parallel with this, right? All 3 of these are parallel, and that's the middle. Then this is the mid segment, right? That has to be the mid segment, right? And then this is base number 2, right? And then this is base number 1, right? Okay, so we agree, right? So let's set it up. We're going to say mid segment, right, is equal to base 1 plus base 2 divided by 2, right? So let's substitute. What would go over here for the mid segment? That would be that 3x minus 2, right? So we'd say 3x minus 2 equals the value of base number 1, which is x plus 11, plus base number 2, which is 3x plus 3, divided by 2. Okay, so that looks quite gross. I know that looks weird. But we're going to just solve it by cross multiplying. We got that. So we're going to take that difficult looking problem and we're just going to divide that side by 1. And now we're just going to do our cross multiplication. So I like working with the x ones first. So 1 times that is still the same thing, right? So we'd still say x plus 11 plus 3x plus 3 equals the other one, right? That's going to be equal to this times that, right? So we can just write that down if we want. That's going to be 2 times quantity 3x minus 2, right? So now we're going to just do our math, right? We're going to work from left to right. So the first thing we do on the left side is we are going to combine our like terms, right? So I see this x over here. I know that's a 1x. And I see the 3x. So let's combine those. 1x and 3x gives me 4x, right? Then I have a positive 11 and a positive 3. If we combine those, that's going to give us a positive 14, right? And that's going to be equal to this times each of those. 2 times the 3x and 2 times negative 2. So 2 times the 3x gives us 6x. 2 times negative 2 gives us negative 4. All right, so all of a sudden it looks a lot easier, right? So now what's our goal? Our goal is to get the x's together, so we're going to add the opposite of that 6x, so we're going to subtract 6x. Subtract 6x on both sides. Right over here, that gives us negative 2x. We're going to bring down the plus 14. These two cancel out, and we're going to bring down the negative 4. Right? Now we're getting quite close, so right? So we want to keep the negative 2x over here, so we want to move the positive 14. So we're going to subtract 14 there. We're going to subtract 14, right? So that means those cancel out. We're going to bring down our negative 2x equals negative, combined with a negative makes it more negative, right? So then we're going to divide both sides by that negative 2. Cancels out. X equals 9, right? So that's what x is, but they're not asking for x, right? We need to still do step number 3, which is substitute. So substituting in for what are we finding? EH. EH is this right here, which is 3x plus 3. Okay, so we're going to say EH equals 3x plus 3, right? Which equals to 3 times, we're going to put that 9 in there, right? Plus 3. Okay, so that means that's going to be equal to, if we put that into our calculator, right? But we can also do the math. Put that on our calculator. We say 3 times 29 is 27 plus the 3. So either way, we get the answer of 30. So that's our answer, x equals 30. Okay, so I know you have this. And so if you have any questions, just let me know.